Right. So first, I want to thank the organizers for inviting me to discuss this very interesting paper. This paper has always been on top of my reading list, and it's a great pleasure reading this paper because it has a very clear contribution. This paper studies a very general problem that is often studied in the computer science literature rather than the economics literature, which probably suggests it's more important than we thought. So protocols based on decentralized consensus avoid single point of failure. That's why we start to analyze all these decentralized protocols, right? We all know that traditional financial system, they suffer from this single point of failure problem, whether it's operational risk or it's financial risk, moral hazard, all of this. But if you decentralize it, this can be avoided to some extent. But the concern is that some of the nodes on the decentralized network can be faulty or be hijacked by hackers. This is what we call the Byzantine nodes. There is this famous Byzantine general problem. Basically, if you consider there are, let's say, 7 generals, they need to either coordinate to attack the enemy or retreat. And if half of the generals attack and the rest retreat, then this will be the most disastrous outcome. So they need to arrive at a consensus. But if there are 3 decide to retreat and 3 decide to attack, then the 7th general probably send a message to the people who want to retreat. It's a retreat. And then send a message to the people who want to attack. And then this 7th general is basically in the position to screw up everyone, to screw up the plan, and to impose losses on all the people involved, right? So of course, this 7th general has its own incentives. So that 7th general is what we call the Byzantine node. But here in the computer science literature, we typically think about the behavior of Byzantine node as some random arbitrary behavior that will disrupt the decentralized system. There are 4 features that typically studies on this Byzantine fault tolerant protocols emphasize. The first feature is that the Byzantine node behave arbitrarily, as I said before. The second is that the non-Byzantine nodes, they are quite concerned about the worst case scenario regarding the Byzantine nodes actions. And this is why the authors use the ambiguity aversion utility function, which I think is very, very reasonable. And the third feature is that the nodes, they always act upon this local information. They are not able to observe the full topology of messaging. Basically, they do not observe how people send message to other people and what is the nature of the message. And last but not least, very importantly, the existing studies typically model non-Byzantine nodes action as following some prescribed strategies. Or sometimes we call these nodes honest nodes. But we all know people have incentives, right? So this is the key contribution of the paper, that is to model rational non-Byzantine nodes by emphasizing their trade-off in terms of benefits coming from reaching consensus and the costs coming from a consensus failure. They also provide an excellent literature review in the paper that touches upon both studies in the computer science literature and also economics literature. I highly encourage you to read the paper, and particularly the literature review. It's very educating. My comments will be focusing on extensions, will be focusing on applications, because as I read through the model, I think I don't have any problem with the proofs. I don't have any problem with any of the result. I think it's a very watertight execution. And as I laid out here, right, you have 4 features that people typically emphasize, but the last one here is really against our, economists' instinct, right? So we want to model rational agents, and this is exactly what this paper does. So I'm not going to challenge the assumptions, the results. So all that I want to do is to provide some extensions. Maybe the authors can think about these comments as writing the next paper, or maybe add 1 or 2 sections to make this paper even more interesting. So first, the authors consider a particular type of Byzantine strategies. I think that's a very relevant type. And what I want to emphasize is that some of these Byzantine nodes, they also have their own incentives, right? As I mentioned at the very beginning, this original Byzantine generals problem, The seventh general who wants to screw up everyone certainly has his own calculations. So maybe it is worthwhile to think about this game not as Byzantine nodes that behave arbitrarily versus rational non-Byzantine nodes. We can think about the rational Byzantine nodes who has their own trade-offs, and non-Byzantine nodes, of course, face their own trade-offs. And when it comes to practical applications, of course, hackers have their own trade-off when it comes to hacking the system, right? So, but I don't think the author can really go all the way, lay out the Byzantine players' preferences based on the game outcome. They can certainly do this, but this warrants a new paper. So what I think is that the authors can provide a discussion on, to what extent, right, the Byzantine strategy profiles analyzed in this paper can be potentially rationalized. On what kind of Byzantine players' trade-offs can be the underlying forces that generate this strategy profile. Maybe 1-2 paragraphs discussion will just suffice. So my second comment is on this, how computer scientists, they model the non-Byzantine nodes. They model them as honest players who follow the prescribed strategies. Actually, if you think about it from a practical perspective, this is not a very bad assumption, because there are costs to rationally deciding on things, right? We need to pay attention, and maybe we don't need to pay attention if we are able to write a piece of code that can automatically execute whatever we want to do on a state contingent basis, right? But not every node has this ability. I certainly do not. Justin certainly has. So, people are different, and maybe you can consider a fraction of non-Byzantine nodes that are lazy and just follow the prescribed rules. And maybe the protocol can give some reward to this non-Byzantine honest or lazy players to follow the prescribed rule. And in this sense, how should we design this prescribed rules, right, for this fraction of lazy non-Byzantine nodes to follow, especially in the context of the rest of Byzantine nodes being rational, and potentially even the Byzantine players can be rational, right? So this paper characterizes more strategic interactions far beyond what we know from the existing literature. But then if we allow a fraction of non-Byzantine nodes to behave lazily and follow the rules, right? The question is, how do we design these rules to maximize welfare? So I think this might also be an interesting application. My third comment is more complicated to do. I think maybe this is for a follow-up paper. So we can think about an extended game, right? Right now, we focus on two outcomes, whether a consensus is reached or a consensus is not reached. But we can also think about the message has a nature of truth or not. So the rational non-Byzantine players and Byzantine players, they can decide whether to send a true message or a false message. And if a consensus is reached, whether the message is true, if a consensus is reached, whether the message is false. And if there's no consensus, right? I mean, what is the original message that the leader gets, the true message versus the false message? So we can think about different scenarios. So why do I pay attention to this particular extension? Because in reality, the incentives of these faulty players, they are often, this goes back to my first comment on the incentive of the Byzantine players, the faulty players. So in practice, the incentives of the faulty players, they are often related to the true or false nature of the message. For instance, I'll be a faulty player if I just send 5 Bitcoins to Jason and I want to reverse the transaction on the Bitcoin ledger. And I'm going to send a false message. And if the consensus is reached upon this false message, there might be a cost imposed on everybody, except me. And so in this case, we can think about first, the Byzantine players, they have their own incentives. And this incentives is particularly relevant if the message has a truth or false nature. And of course, if we think about this, right, the types of agents can switch over time between a faulty and rational non-faulty behaviors, players. So I think this point towards a more general direction of research. That is, if we think about the design of decentralized system, right, how the consensus is arrived. There are players who have conflicts of interest. We can label them as Byzantine players, non-Byzantine players. We can label them as honest, dishonest. We can label them as players follow prescribed rules and discretionary player who just make rational decisions, right? But what is important is that these players, they have conflict of interest. And under this more general context, how do we design a consensus protocol? But this paper certainly is guiding us towards this direction. So I think it's a very clear contribution. There are new insights and very practical insights. So my comments are in these three areas, again, largely about extensions and some discussion, one paragraph or two. But I think the paper is quite complete already at this current stage. Thank you.